The only way to represent the solution set to a system of inequalities in two variables is to graph it. The solution set will be represented by a shaded region. The steps to graph are 1. Write the inequality in the form necessary to graph if it were an equation. Step 2. If the original inequality has the symbol less than or greater than, then we're going to use a dotted line or curve. If the original inequality had the symbol less than or equal to or greater than or equal to, then we use a solid line or curve. Next, we will pick a test point inside one of the resulting regions. If the test point works in the inequality, shade the region containing the test point. If not, shade the other region. Before we look at a system of inequalities, let's look at just a simple linear inequality. 3x plus 2y is less than 6. We can change this to an equation and graph this. Let's isolate the y so that we can put it in slope-intercept form and graph. Subtract 3x and then divide by 2. Y equals negative 3 halves x plus 3. The y-intercept on our line is 3. And then we have a slope of negative 3 halves. So we'll go down 3 and right 2. And we can continue that pattern, getting as many points as we need. We could also go up 3 and left 2 if we wanted more points in the opposite direction. And now when we play connect the dots, we need to ask ourselves, is it a solid or a dotted line? Since the original inequality is strictly less than, and we don't have equality, this is going to be a dotted line. Notice that the line splits the graph into two regions. We'll next choose a test point to determine which region is the solution set. You can pick any point you want as long as it's not on the line you just drew. The easiest point is typically the origin. So let's test 0, 0. And we're going to test it in the original inequality. 3x plus 2y is less than 6. Plug in 0 for x, 0 for y, and we're asking, is that a true statement? 0 is less than 6. That's a true statement. So we chose this point, 0, 0. We tested it and found that it's a true statement. That means that every point on that side of the line is true. So we're going to shade the entire portion that contains 0, 0. Every point in the shaded region is a solution to the original inequality. It also means that every point on the other side of the line is going to be false, so it's not part of our solution set.